This is House Planning Help episode 26. Hello, I'm Ben Adam Smith, and this is the podcast for you if you want to find out about self-building or renovating. I'm exploring what houses we should be building in the 21st century alongside my own personal goal of creating an energy-efficient home. In this session, we are looking at achieving airtightness, and the very knowledgeable Paul Jennings from Aldas, he's my guest. Whew, how are you? I hope you're okay. It's been a busy couple of weeks for me. As you might have heard in the last episode, my production company Regen Media is producing some video inserts for the UK Passive House Awards. Well, at the time of recording, they take place tomorrow. So it's very exciting. We'll find out who the winners are, and soon I'll be able to share the links to these videos as well. So that will be in the next podcast. But the awards, I suppose, slightly different because you expect when the building's complete, let's have the awards ceremony. Does it win an award? But Passive House is the as-built standard, so a lot of these buildings have been used for the last few years. In fact, that's, I think, one of the criteria for the Passive House Awards to be an entrant. You've got to have some data from the last couple of years. Has the building performed properly? So I think that's really, really good. It's getting to the point of making sure that what's on paper does actually perform when it's been constructed. But seeing all these projects, they're so varied as well. I think it's going to be tough to choose the winners. But I got to get to Lancaster co-housing, and very soon we'll have an episode on that construction there. In fact, I think Paul Jennings, who we speak to today, he was involved with Lancaster co-housing. The co-housing concept is new to me, and I just find it fascinating. We looked at some social housing as well, Ditchingham, the racecourse bungalows, these projects addressing fuel poverty. And at the end of viewing all of these projects, whether it was the ones in the domestic housing category as well, you just got the impression that people that had tried to reach the Passive House standard had seen the light and there was no looking back. So it was a really positive mood to come away from that, and I hope that you can check out the next episode because we'll have all of those links that we talked about and also the results from the UK Passive House Awards that I shall be at tomorrow as well. Anyway, let's get into the main content for this episode. We're talking about achieving airtightness, and my guest is Paul Jennings from Aldas. I started by asking him for a little bit of background on his career and how he got into air testing.
I did an engineering design degree and started working for an energy charity in London. And courtesy of Ken Livingstone, the GLC at the time, we were provided with this test equipment from Canada. This is 25 years ago now, to try and promote energy saving and better housing in London. So we went around London for several years testing council flats, council houses, some private stuff as well, but mostly public sector, looking at improving the housing because fuel poverty was becoming more of an issue. People were concerned, quality of health, asthma, mould growth, all those things were coming around more so. And with fuel prices going up, which of course is happening again now. So thought it was a good idea to try and improve the UK housing stock, building stock. Still the case because we've done very little over the 25 years since I started. But that's fundamentally how I got into airtightness.
For some reason, I seem to think of airtightness and increasing it as something that's happened in these last few years, but it's always been a requirement, has it, of building? Or maybe you could give us a bit of the history of how airtight buildings have been.
Well, historically, some buildings have been very airtight because of the nature of the construction. If you have plastered walls, lime plaster originally over stone, that's pretty airtight. One of the most airtight structures I tested was part of Gloucester Cathedral, because it's 600 years old and the roof's been sitting on stone and it's got plastered walls, was very airtight. Whereas you can test modern housing, certainly housing built by developers in the 70s, 80s, 90s, and it's disastrous. It's much worse and much less fixable than much of the stuff from Victorian Edwardian going back. I've said for some time that we can fix up Victorian properties, we can make them airtight, but for a lot of the more recent stuff, it's too much to do. We'll end up throwing them away.
Maybe we can have a definition of airtightness then to kick us off.
There are two primary measures of airtightness. One is called air permeability, which is the amount of air which flows through the fabric, the walls, the roof, the floor of a building per hour at a particular pressure. And the usual pressure we work to is 50 pascals, which is not a lot. 50 pascals is 5 millimetres of water. It's not a huge pressure. If I'm doing a training course, I say to people that you apply 2,000 pascals if you have a milkshake in a burger bar or similar. That's 2,000 pascals with your mouth, and it doesn't hurt you. People don't need to worry about the budgerigars or the rest of it. So it's relatively a small pressure, and that's air permeability. And that's in the building regulations. That's what we use in building regulations for new build. And then the other measure is called air changes per hour, which is what it says on the tin, really. It's a volumetric measure. It measures how much air passes into or out of a building per hour, again at the same pressure of 50 pascals. And that's most appropriate for buildings that have heat recovery ventilation, that are conditioned buildings, which will tend to be more airtight. And certainly you want that air, warmed air, cooled air, going through the ventilation system rather than leaking out around doors and windows and through cracks, gaps and all the rest of it. So basically air changes is what we use for more airtight buildings, like the Passive House, which has a very stringent airtightness target down at 0.6 air changes, whereas building regs is still at 10, maximum of 10 air permeability. So that's about 16 times more onerous. And of course, the closer you get, the lower you're aiming for, the harder it is. It's diminishing returns. Getting air tightness down from 10 to 5 is easy. Getting it from 1 to 0.6 is very hard. Generally, obviously this varies according to building design, building type. But above all, it varies according to the builder and the quality of the builder. And that's the biggest issue we face with delivering air tightness, is how do we make our builders do what they need to do, work to the sufficiently high standards. And, it can be pretty onerous.
So where do we start then when we're trying to make, let's consider a new build airtight? What is the process?
Well, the first part of the process is to look at the design, because there are things that you can do that make it easier to achieve airtightness. One of them is common in Germany, is where your upper floors are concrete rather than suspended timber like ours. Wherever you have suspended timber, you have voids which air can pass through. And it's fascinating to do a test on a 3-storey townhouse and point out to the occupant the room thermostat that's on the internal wall of the mid-floor living room, and there's air coming through it when you're testing it, because it's connecting through the voids in the walls and the floors. So one thing we could have more of is solid upper floors. That would make a significant difference on the design side. Also, just going for warm roof construction. Any cold roof has often a very tricky detail at the eaves where you have to try and maintain air tightness, but you also want ventilation into a cold loft space. So trying to have those two things in what is becoming a tight space in that angle in the eaves often becomes difficult for people, and one of the places it goes wrong.
What materials do you use to achieve the airtightness? I'm assuming that if you have a wall, then that is quite easy because it's one solid space, and let's assume there are no windows in there, but it gets more complicated, doesn't it, considering what the space is?
Yeah, fundamentally, most building materials are pretty airtight. Glass is airtight, plasterboard is airtight, solid timber is airtight. Blockwork varies a lot. There's some blockwork you can blow through. I've had blockwork walls that you can blow through. And, it varies. One of the things we say for new build, if you have blockwork coming off an external wall into the dwelling, you have to make sure it's airtight for at least 1 metre into the dwelling. So you basically have to plaster, if you're doing a wet plaster system, on the return internal partition walls as well as on the inside of the external wall. And even then, we've had cases where they're using recycled power station ash, fuel ash, in the blockwork. They can be very, very porous, and 1 metre's not enough. You've had air running through internal dividing walls by up to 4 metres, which goes beyond what you're expecting. It goes outside the design and then becomes a problem. And so often with this, it's where you have variations, where people move a duct, people change a window size, people discover that blockwork's leaky where it's not, it goes wrong. Because if you've got a program, and if you're smart for airtightness, you have a program, because it doesn't happen by accident. Good levels of airtightness. Once you're getting down below 3, say, I would tend to say 3 is the minimum standard you're going for. And 3 is the silver standard from the Association for Environment Conscious Building, which tends to be the minimum I would work to. And then obviously going down to passive house at 0.6. So if you're in that band, you want to deliver airtightness, you have to plan for it. You can't just specify the target. You can't even just specify the materials. You have to specify the process. You have to specify, is the design getting reviewed, checked, who's doing it, making sure you have a set of what we call air barrier drawings, which most people think of as a red line drawing. So you have a drawing, plans, sections, details with the red line showing what the airtightness is, where it is, with notes saying it's this material here, it's this package of works, because you need not only to know what the materials are, you need to know who's doing it. And then there's the process of going through and checking that, what we call a design review, of making sure that it all joins up. So you've got the airtightness in the walls, you've got the airtightness in the roof, and you've got the airtightness joining the two at the eaves. And I've had occasion where it's missing. I did a design workshop on a building society headquarters, and we were sitting there, and the main contractor says, this is part of the package that the roofer does. It joins with an EPDM membrane, it's joining the roof to the top of the blockwork walls. And the roofer said, no, we're not. And that was it. That was the value of that half-day workshop straight there, because that building would have been problematic for years.
So is this a learning curve for a lot of people? If you want to start becoming more airtight, there have got to be mistakes, or how do you avoid making these mistakes?
Well, I think there will always be mistakes. It's very difficult to get perfection. And part of the problem with UK construction is that we hide our mistakes. We don't deal with our mistakes. So I've had this before where something's been put in the wrong place. A hole for a boiler flue, a hole for a heat recovery duct or an extract fan, and it's put in the wrong place. And instead of being owned up to and acknowledged, say, yeah, we put it in the wrong place and that's fix it, it gets hidden. And then suddenly, weeks or months later, you're doing a test and it's like, why is there huge air leakage into this void? Oh, that's why. Because one of the things people don't understand is that as soon as you have voids, so as soon as you have a cavity wall, air can go anywhere. So you may not see a hole on the outside of the building, but if there's a hole in the inner leaf connecting to the cavity, that's as good as to outside. And it's not just even with new build and cavity walls. I've had this several times with old buildings where you have basically a stone wall, a thick, even half a metre thick in churches and stuff. And you think of it as a solid stone wall. But actually, it's stone, rubble-filled cavity stone. And that rubble will not be airtight. And it's amazing the amount of air that comes through those walls. Now, as soon as you stick lime plaster on the inside, it's gone. It's dealt with. But then you usually have an issue at the top, coming into window reveals or coming into the roof joint. But again, it's something that people just have no expectation of. People do not expect buildings to leak where they do leak. They don't expect air to transmit into the inside of a building. I did a test on Saturday on a refurbish of a nice 4-storey Edwardian townhouse. And we had a pillar in the basement, which had been lime plastered, and it had a switch box on it, and air was coming through this switch box. This is yards away from the outside surfaces. So where is that air getting to it? Now, we think it's connecting to a chimney flue from the existing chimneys. That's why so often we're finding if people want to deliver good airtightness in refurbishment, they do tests to find out what's going on, because you have to know. Because apart from anything else, you may find you're wasting your efforts. If you have a leaky building and you don't tackle it because you don't appreciate it, you spend thousands on a heat recovery ventilation system, and it's all a waste because the air is leaking out through the walls or around the roof joists or wherever else it is.
How do you test for air tightness then?
Essentially, you have a calibrated fan. Small fans, big fans, and very big trailer fans. And you mount it in an open doorway or an open window. And that could be mounted in a piece of wood, or we have various adjustable door systems. And the fan's calibrated. It will have varying ranges of how much air it will blow from small to very large. And normally we start by sucking air out of the building. It's called depressurization. So the building's at lower pressure. So atmospheric pressure forces air back through the cracks, the gaps, the leaky dampers, the windows, the draft seals aren't quite right, whatever else there is. And if we can get it above about 25 pascals, then effectively we've created a strong draft, a permanent draft, while we're testing. And we can go around and find it. You can often just feel it with your hand. If you're not sure, you put your eyeball next to it because your eyeball's even more sensitive. We can use different sorts of chemical smoke, stage smoke. We can use acoustic testing. We can use little extending anemometers. So you have your little extending tube that you stick next to where you think the hole is. We can use infrared cameras to help us find things because, especially in the very airtight buildings, it can be the coldness where the air's leaked that shows you where the leak is rather than feeling the leak itself because it's so small at any one instant. But after 10 minutes of cold air, it starts to show up on the thermographic camera.
So these tests, how often do we have to do it when the house is being constructed? Because I've seen them happen quite a few times and I'm still unsure. And even afterwards, they keep on testing.
Well, for most construction, testing is required under building regulations. And basically, for non-domestic, it's required for all buildings above a minimum size. For houses, it's sample testing. So you wouldn't normally have to test every house, although the sample size do increase as the target gets a lower value for the airtightness. And one of the issues that's being talked about at the moment is the fact that the building regulations say if you do a test and it fails, you not only have to fix it and retest it, but you have to test another one of the same type as well. The sample size goes up. Yet there have been no failures or almost no failures reported. And why is that? Well, we know why that is because any builder, sensible builder, says, well, actually, let's make this a leak location exercise, not a test, and we'll fix it, and then you can test it again, which is basically, it's legal, but it's definitely against the spirit. And we definitely, I think, as a nation, are building in problems for the future with poorly performing houses where we have small sample sizes on large volumes, large numbers of houses, and especially where they're timber frame. Because one of the fundamentals underlying this is where air moves, it takes water, and water concentrates around the points of leakage. So, for example, if you have a socket box in a wall of plasterboard, it'll be the socket box where almost all the leakage is, and probably almost all the moisture ends up in the wall. So you can very easily get to a point where you're getting interstitial condensation, problems with rotting of timbers in walls. And I know I'm a pessimistic cynic, but I'm expecting there to be another wave of problems with condensation in walls showing up in the next 5 or 10 years.
How long does this airtightness last? Presuming, as with any building material, you expect degradation over time.
The fundamental truth is we don't really know because the UK is abysmal at research. So we're not doing the research to go back and find out. Obviously, the suppliers of materials, especially the better airtightness materials, do accelerated aging. And they say, oh yeah, we've proved that our product will last for 50 years. But it's not in a 50-year-old building. You know, it's been in a laboratory with accelerated weathering, blah, 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 to demonstrate that it has a robust life. Having said that, most things are fairly stable. It's the joints, the interfaces, the penetrations that move. Obviously, mastic varies from very good, high-quality mastics, which have a bit of give and will allow the building to move, to shrink, thermally change over time. And then you get at the other end of the scale, you get the absolutely very cheap builder's cork, which I've seen crack within weeks of being applied. So between doing a preliminary test on a building and then an acceptance test 6 weeks later, say when the services have been installed, this mastic has failed, this builder's cork has failed. And anybody doing airtightness should understand the difference because it's a very significant difference.
Now, I may be opening a can of worms for myself here. When we talk about vapour open and airtightness, I don't think I understand this at all, how you can have both those things, an airtight barrier that is vapour open. Do you want to try and explain that one?
It's the difference between allowing air through and allowing moisture through, fundamentally. Moisture will wick through materials, so it will soak into a surface, pass through the material, come out the other side. That doesn't require a hole that will let air through. And That's the fundamental. We have buildings which we call vapor permeable. They used to call them breathing wall, but that's a misnomer because it's not. But vapor permeable buildings will allow moisture to pass. Some of them have these recent, what they call intelligent materials, which vary according to temperature and pressure in which direction they allow moisture to move. But again, they are airtight. And nobody should be under the illusion that if they want a vapor permeable building, they have to make it airtight. Because it's absolutely ludicrous. You have this supposedly vapor permeable building with a 1 millimetre wide crack for a metre, and that's letting through 99% of the moisture.
Okay, that sorts that one out. A couple of questions as we come to the end here. I know that airtightness is one thing, and obviously we know about insulation, but people forget ventilation. How does it work that as we crank up the airtightness, we need to think about ventilation?
Well, there are two different things. And what's true at the moment is most UK houses have too much ventilation if the wind blows and not enough ventilation if the wind doesn't blow. So basically we have the worst of both worlds. And as we move to more airtight, indeed very airtight with passive house buildings, you have to have ventilation. You can't do without it. You don't need very much. People worry about this, but you don't need very much movement of air to give you the oxygen you need to breathe. We reckon about 30 litres per second per person for moisture control, and for breathing, depending on exercise levels, 2, 3, 4. It's an order of magnitude difference. You will be getting black mould going out your ears before you suffocate in an airtight house.
Okay, and also indoor air quality. How does that fit into this equation?
Well, it's another part of airtightness. When we're doing airtightness, we have to think that there is less dilution of pollutants happening. So you have to avoid paints that are going to give off volatile organics, for example. So you basically need to be careful about specification of paints, of furniture, things like new computers giving off lots of toxic materials. All of these things become more of an issue in an airtight house. But of course, the big one is moisture, and especially during construction, because if you're doing an airtight project, very likely you'll have much more wet plaster than plasterboard. It's an easy way to do airtightness is having wet systems. Of course, that means there's drying out that has to happen. And one of the things we're seeing in some of the passive houses, the airtight properties, is mould during construction because they're not drying out. Because, of course, the heat recovery system isn't operational for a long while later in the build than the walls are up, the plaster's on, and it's trying to dry out.
What are the key challenges then of achieving airtightness? As a client, I know that I want something that's energy efficient, so this is going to be important to get an airtight building. But what do I need to bear in mind?
Well, if you're a client wanting airtightness, first of all, assuming you're not doing it yourself, assuming you're employing contractors and architects.
I will be.
What's their track record? What have they done? Have they done it elsewhere? What have they achieved? What's the best they've achieved? Because if they're just a bog standard builder without any knowledge of airtightness, then you'll be paying for their learning curve.
Okay, all right.
So first off, experience. Then, of course, the whole process. And again, it depends what level you're working to. It's much more onus working at Passive House than working at a target of 3, the ACB Silver Standard. It's horses for courses. If you're targeting the very airtight property, then you've got to pay more attention and you've got to plan, you've got to think it through, you've got to avoid variations, so everything's specified, designed, planned, review the airtightness so you're very clear and the contractor's very clear what's going where, when. Making sure that contractors are doing the toolbox talk so that everybody on site has bought into airtightness. It takes very little time for one plumber or anybody to completely compromise airtightness.
Do you want to leave us with a final thought then, or perhaps something that I haven't asked you that you think I should be asking you?
Fundamentally, we need to be delivering better quality airtightness, particularly in refurbishment. We're not bad in new build, or potentially not bad in new build, but in refurbishment, we've really got to learn a lot. We've got to get the skills base enormously improved. We've got to be doing much more testing of refurbishment projects so people understand what the issues are and they see the difference before and after. Because not only are we talking about energy efficiency, we're also talking about we want buildings to last. Sustainable construction means construction that is not rotting from interstitial condensation 5, 10, 15 years down the line. We want it still there, 50, 100, for our great, whatever grandchildren to be able to live in it and use it. So we want that property to be airtight, so it's moisture protected against moisture damage and it lasts. And I'm afraid all this eco-bling, all these solar panels, all the rest of it, there's a place for it, but you've got to get the building fabric right first. That's the fundamental, fabric first. And it's a crying shame, and most of UK construction industry needs to be taken to task for the poor quality it does in refurbishment around airtightness and quality control generally.
Paul, thank you very much.
You're welcome. Hopefully it's useful and not too much of a rant.
Great stuff from Paul, and I like a good rant every so often. You can find the show notes for this episode at houseplanninghelp.com/26. We've also got some photos of Paul going about his air testing. Finally, I'd like to thank everyone who's reviewed us on iTunes. It really does raise the profile of the podcast, and I'm pleased to say that last month was our most successful month, the largest amount of downloads since we launched, so that's great stuff. But if you haven't had a chance to do it yet, I really would love it if you could do an iTunes review, and I'll put a link in today's show notes. Much appreciated. Looking ahead to our next session, should you hire a project manager for your house build or perhaps do it yourself? I'll be chatting to Mike Jacob from Trunk Low Energy Building, and we'll get his viewpoint on that. Until the next session, take care.